Alright guys, we're going to look at a new chapter now. So the new chapter, chapter 19, we are doing some spherical geometry. So what that means is looking at geometry of spheres or circles, rather than we've been looking at triangles. Okay, so we're going to start off with exercise 19a, and we're going to be looking at arc length. So before we even look at what arc length is, just a couple definitions. So if we have a circle, think about in a movie, if you've seen Top Gun, when there's like a radar, and there's like planes popping up on the radar. This radar line is like traveling around the circle. So that's how you remember radius, because it's because of radar. So the radius is half the length of the circle. The full length, so between 2 points that pass through the center, is the diameter. So if the diameter is 10, then the radius would have to be 5. Okay, so that's just good to keep in mind. Now, if we then look at what an arc is, because we're going to start with arc length. So if we have 2 points, say A and B, and then we just connect point A to the center and point B to the center, it creates this arc. There's 2 arcs actually. The minor arc is the smaller side, so the smaller part of the circle that connects the 2 points, and the major arc is the bigger side that connects the 2 points. Okay, so that's what an arc is. Now, to calculate the length of an arc, let's look at this one up here. Well, we've got our point A, we've got our point B. Now you connect it to the center, it makes an angle here, theta. So it might be 30 degrees, it might be 40 degrees, or whatever. We use this angle to calculate the area, the length of the arc that connects A and B. So the formula is the length, so we've just called the length S, but the length is pi times the radius times the angle divided by 180. Okay, so this is the length of an arc, and we'll look at an example. Okay, so example 1. We've got a circle, it's got radius length 10, and the angle subtended at O. So what this means is this angle here is one subtended, so looked after, at O, by arc ACB. So then the reason they're putting C in there is so they know you have to calculate this arc and not the big one. Cool. It's got magnitude, so the angle's 120 here. It doesn't tell us in the question, but whatever. And they want us to find the length of the arc. Oh, didn't want to work. So our length is just equal to, we've got pi, remember that's on your calculator on the bottom left hand side, times the radius, which is 10, times the angle, which is 120, all divided by 180. If I chuck that in my calculator, I will get pi times 10 times 120 times, divided by 180. So 20.94 centimeters. Cool, so our length is 20.94 centimeters. So this here, 20.94 centimeters. Cool. Have a crack at questions 1 to 4 now.